All right, hey guys, this is a chapter about stoichiometry, but we're going to build up and we're going to go stepwise into converting from the mass of one substance into the mass of another. This is actually one of my favorite subjects in chemistry. A lot can be done with this, and it's actually quite simple if you follow the steps. But today we're going to look at mole ratio. It's a very important aspect to stoichiometry, and without the mole ratio, you can't do stoichiometry. All right, so what is stoichiometry? Okay, stoichiometry is a useful tool that we are able to determine how many grams of a substance will be produced if a reaction takes place. It expresses the quantitative relationship between reactants and products in a chemical equation. Okay, as long as you have the correct balance equation and you're given a mass of one of those substances, you can convert to the mass of any of the other substances using stoichiometry. Okay, so for example, if you have the mass of one reactant, you can find the mass of the product that is formed using stoichiometry. So it's an effective way to figure out how much mass of a substance will be produced through a reaction. Okay, it's quite interesting. It's kind of like what got me into chemistry. All right, so there are a few things we need to calculate a stoichiometry problem. Okay, the first thing is the balanced equation. If you have the equation, perfect. Make sure it's balanced. If you don't, write the balanced equation out and make sure it's balanced and double check that you have the right coefficients expressed in your equation. The other thing is the mole ratio. That's very important, and that comes directly from the balanced equation. So if you don't have a correct balanced equation, you're not going to be able to do this. So these are the two necessary things that are in all textbooks that are explained, and they are necessary for the correct calculation. So let's take a look at how to calculate mole ratio. We're just going to do two problems, and you'll understand exactly how to do it. Okay, so what is a mole ratio? Well, mole ratio is a conversion factor that relates the amounts in moles of any two substances involved in a chemical reaction. Okay, so here is the formula for mole ratio. B mole W over A mole G. Okay, what is this? Well, it is a conversion factor, but where do we get the little letters and the big letters from? Well, we get it from the balanced equation. Okay, now how do we know which are those? Well, you have to read the problem that you're given to understand which is the W, which is the G. So let's take a look here at the key. So the W is the wanted. Okay, now what is a wanted? Obviously from a math, it's the question you're solving for. So what you are trying to solve for. Little b is the coefficient for W. So little b is the number that's directly in front of the wanted found from the balanced equation. So you need your balanced equation. G is the given. It's basically what you start with. It's the number that you're starting with that's in the problem. You'll have one number, and that's your given. It's a given. Okay? And the given is going to be the first number you write down on the paper. The little a is the coefficient for the G, or the given, and it's found from the balanced equation. So it's the number that's right before the formula for the given in the balanced equation. So make sure your equation's balanced before you even go through it. Have to be accurate. Okay, let's calculate a mole ratio. All right, let's look at this problem here. We have this problem. Given the following equation, calculate the mole ratio to convert from mole NH3 to mole H2. Okay, now we're going from NH3 to H2. So NH3 is your given and your H2 is your wanted. Okay, so you have to make a rational decision about which one's which. You really have to slow down and think about it. Okay, then when there's numbers that are in front of each one of these formulas, okay, there's a 1 here, a 3 here, and a 2 here. Those are also very important numbers to look at. So our given and our wanted, our B and A, can be found directly from this here. So what we have is, from the formula, our mol NH3 is our wanted. So let's look at our list right here. I'm sorry, mol NH3 is our given. We wanted the H2. So H2 is your wanted. From the balanced equation, we see the H2 here. The number in front of that is your B, the 3. So 3 is your B because the H2 is your wanted. Now your given is the NH3, okay? NH3, which is your given. The number in front of the NH3 is a 2. So these are your 4 pieces of information you can plug into the mole ratio. So let's check it out. So here's your BMW over AMG. Okay, so we put in the B, the 3 mol H2, and the 2 mol NH3 for this right here. Okay, and this is the conversion factor that we're going to use if we have this problem and if we go from NH3 to mol H2. Okay. Okay, the next example I want to look at, it's the same thing, just a different formula. So, given the following equation, calculate the mole ratio to convert from mol Al2O3, which would be your given, to mol O2, which is your wanted. Okay, so here the balanced equation is we have the 2 here, 4 here, and 3 here. So those are your coefficients. Okay, so our wanted is mol O2. There's a coefficient of a 3 in front of it. Your given is your Al2O3, and the coefficient in front of that is your 2, which is your A. So your A is a 2, your B is a 3. Okay. So, taking this information right here, we plug that into the formula, the BMW over AMG. Okay, so 3 mol O2 over 2 mol Al2O3. So this is the conversion factor that we use when we're going from Al2O3 to mol O2. And we're going to see this again. This is just one simple step that I want you to be familiar with how to get the BMW and the AMG from a formula. Okay, because the next series and steps we're going to go through are going to be a little longer. We're going to use this and apply this to other things. So this is one single step that we need to be familiar with. Okay, so it's very simple. You just need the BMW AMG. You need to know your balanced equation, make sure your coefficients are correct, understand which is your given, understand which is your wanted. So you're going from your given to your wanted. Okay, just like any other math problem in math class. Okay, you're solving, looking for that answer. All right, guys, that's where we're stopping.